Hello dear students, today we are going to discuss the topic that is DMA. DMA topic is of Computer Architecture and Assembly Language, and the topic DMA stands for Direct Memory Access. So let's start the topic. DMA means Direct Memory Access. So this definition has three terms. This term has three terms, that is direct memory access. So in direct memory access, direct means when the controller is allowed to access the memory directly without the intervention of CPU. That means there is a DMA controller which will take the control of all of the buses from the CPU, and then with the help of those buses, the transfer of data between memory and input-output devices will be done. So DMA is a crucial concept of computer architecture. It allows all the peripherals to transfer data from and to the memory without the involvement of CPU. Why we use DMA in computer architecture? Because we want to basically reduce the overheads of the CPU. Like if CPU is unnecessarily busy in input output device and memory data transfer, then what we will do, that controller will be given the access of the buses and then the data will be transferred. So it is a technique between memory and peripherals in which we allow the data transfer without the intervention of the CPU, and CPU is not involved in this process. We basically free the CPU so that CPU can focus on the other task. Why we use DMA? Because DMA is a model or is a concept through which we can transfer the data from the memory or to the memory. Like if you are using load and store instructions, then you can transfer the data. Basically DMA helps in speed up data transfer, as CPU and the other input output devices and the peripherals, they have distinct speed limit. So CPU transfers the data speedily, but the input output and other peripherals don't have the same capacity or the speed limit. So DMA takes over the control of the buses and reduce the workload of CPU and transfer the data. We basically do the parallel processing in this topic so that CPU can execute other tasks and DMA is doing the memory or data transfer. Working of DMA. DMA is basically direct memory access. The idea was invented so that you can free up the CPU so that the CPU can perform other important tasks, and DMA can perform the task of data transferring between memory and input-output devices. So CPU initiates this transfer. How CPU initiates this transfer? Basically, CPU has three kind of buses: data bus, address bus and control bus. So with the help of these buses, the data gets transferred by the CPU. But when the DMA intervenes or the CPU initiates the DMA transfer, at that time what the CPU does, it basically relinquish its control of the buses and provide the control of the buses to the DMA controller. What is DMA controller? DMA controller is the actual kind of operator that perform the task. What kind of task? That is transferring the data between input output devices and the memory. So CPU is the one that initiates a data transfer request. Then after the CPU relinquish its control of the buses, the DMA take over the control of the buses. The buses are data bus, control bus and address bus. With the help of these buses, what DMA do? The DMA transfers the data from the memory to the input output devices. While the DMA is doing all the data transfer, CPU will not intervene in this working. Means CPU is busy on other task and DMA is doing the task, that is the working of DMA. Once the DMA complete its task, then what the DMA will do? It will now give up the control of the buses and the control will be taken over by the CPU for the further execution of the process. Next is DMA controller and its role. So what is the role of the DMA controller? DMA controller can be abbreviated as DMAC, that is DMAC means direct memory access controller. It manages all the operations of the DMA. The communication is done between CPU and memory using all these control signals. The control signals will include the write operation, the read operation. So as the CPU has three kind of buses, that is control bus, data bus and address bus, it also has some kind of registers. Why we use registers in cal? Because we want to store some kind of data so that the data can be transferred from the register or to the register. So basically register is what? A type of memory, like cache memory. Register is also a memory. So in register, what we have? Memory address, word count address and control status. In memory address, data count and control status, memory address is the address where we want to transfer the data. Like what is DMA? It will directly access the memory. How will it will access memory if it doesn't know the address of the memory where we have to send the data or from where we have to access the data? So memory address is used basically to know that from where or to where the DMA AC has to do the task, memory part जहाँ पे आपका DMA काम करेगा. Then data count. Data counts means the number of words that needs to be transferred. Like if when the CPU gives over the control of the buses to the DMAC, then CPU at that time of granting the buses to the DMAC, it also provides the data count. Data count is like word count, how many numbers or how many data needs to be transferred. So in this the back counting is done, like if 10 number of words or data needs to be transferred, then after transmitting one data it will be 9, after transmitting another data it will be 8, and similarly when the data count will reach 0, then the buses will be given again to the CPU. And control and status is basically to supervise all the functioning of the DMAC. Now in how many ways or in how many modes the DMA transfer is done? So basically, if you refer Morris Menu, the standard book of computer architecture and assembly language, you will see that there are two modes that are specified in that book, that is burst transfer and cycle stealing. But we have another mode according to the research, that is transparent mode. So burst transfer is what? Burst means when a large amount of data is transferred, means the whole block is get transferred in one go. Suppose you have 10 words, then these 10 words will collectively make a block, and then the whole block will be transferred in a single go, and then CPU will wait until those all 10 blocks will get transferred. So CPU will not intervene the process until the completion of that task is done. Cycle stealing means, as you can see the name, this is cycle stealing. Stealing means to take over something, or in Hindi we can say stealing means chura lena or le lena. This is stealing. So cycle stealing mode is what? Cycle stealing mode is when the DMA takes control of the system bus for a small data transfer, then it returns it to the CPU. Like if you want to transfer again, that's then the 10 words, then what cycle stealing will do? Suppose you have done the data transfer of 5 words, then CPU can take over the control of the buses at the time of 6th word data transfer. But in burst mode, it cannot be done until the whole block is transferred. So this is the difference between two, burst mode and cycle stealing. Next one is transparent mode. Transparent mode is when the DMA works only when the CPU is idle, ensuring no performance loss. This means that the DMA will only work or will only take over the control of the buses when the DMA controller gets to know that CPU is idle and is doing nothing with the buses. Then only then this mode will be done. What are the advantages of DMA? So the advantages of the DMA is actually related with the concept of DMA. Why we introduced DMA, or why we need to learn what is DMA? Because CPU has a efficiency in doing things, and the two terms, that is efficient and effective, is always associated with CPU. So if the CPU is not able to perform any task effectively, then what is the sense? So DMA was introduced so that faster data transfer can be done without the intervention of CPU, and to reduce the CPU overheads so that it can do another important task. That's why DMA is introduced. Effectively managing the memory, that means when you have to do large data transfer, then DMA is also important, or you can use DMA. The DMAC will take over the control of the buses at that time and do the large data transfer using the burst mode. In this slide, we have discussed type of modes, that is burst mode. Transfer of data block in one go. Support multiple peripherals effectively. So I hope you all understand what are peripherals. Let me redefine it. Peripherals are all the devices that are connected with the processor, like all the input and output devices, or the peripheral devices, or we can say. So this is the advantages of DMA. Where we use DMA means what are the applications of DMA? So hard disk and SSD data transfer, graphic card operations, network communication, audio and video processing, embedded systems, and real-time applications. These are the applications of DMA. What is the meaning of application of DMA? That means you are using direct memory access in all these areas. Means while you are communicating with the network, or a communication is there in the networks, then DMA is there. Without the intervention of CPU, you can also communicate. Audio video processing is done with the help of DMA. So this is the main block diagram of DMA. I have taken this diagram from Morris Mano. This is the standard book of computer architecture. This is also known as the Bible of the computer architecture. So these four components are the main components in DMA, that is CPU, then memory, RAM, then आपके input output devices, these are the peripheral devices, and then DMA itself. So what is the working of this diagram? See, you have in CPU BG and BR. So BG stands for bus grant and BR stands for bus request. And CPU also has a signal, that is interrupt. In DMA, the same data bus, address bus, read line and write operation is shared. RAM is also sharing read control, write control, address bus, data bus, and there is input output device. So from where the CPU initiates, we have discussed in this slide that CPU initiates. Yes, here. We have discussed here that CPU initiates a data transfer request and then DMA takes control of the buses. So in this diagram, let me explain that how it works. So basically, first of all, the devices send a kind of request to the DMA that we want to communicate with the CPU, with the memory, and with the help of you we can do the communication. At that time, what DMA do? The DMA interrupt the CPU so that the CPU can get to know that input output devices wants to communicate with the memory. Then CPU will receive a bus request. This bus request will be sent by DMA. DMA is direct memory access, and then after the CPU receives the bus request, the bus will be granted to the DMA. Then an address is selected by the CPU that from here to here the data transfer will be done. That is the word count, what we have also discussed in the previous slides. Then we will let the CPU free and DMA will take over the control of the buses, and with the help of read control, write control, address bus and data bus, DMA and RAM, that is memory, and input output devices will communicate. When the DMA the control of the buses, the DMA also acknowledges the input output devices that now I have the control of the buses. Now you can communicate with the memory with the help of me. Me here is DMAC, that is direct memory access controller. So I hope you have understood this topic, direct memory access. So let me summarize this once again. So I hope you get to know the word that it basically allows the peripherals to directly transfer the data to and from system memory without the involvement of CPU. That means once the CPU has granted the buses, DMAC will take over the control of the buses. The data will be transferred, and when the data gets complete transferred with the help of data count, then the buses will be returned back to the CPU. Thank you so much.